We're in Algebra 1, Lesson 9. We're in our new Unit 9-1. Today is January 28th. Please put the date. Did I update the date? I did. Whew, no extra credit there. All right. Make sure your name and date are on your notes. Today we're talking about systems of equations in general and how to solve them with graphing. So let's start out with some vocabulary. When I say system, what do I mean by that? Does anyone want to take a guess for their participation card, or should I just go ahead? Yeah, go ahead, Andres. Yeah.
Mx plus b equals x.
Okay, so that is the form of a linear equation. Let's come back over here. So you still get XP and your card can come in. That's not exactly what I'm looking for. It is an attempt. Anyone else want to give an attempt, Gunnar? No? Okay. So when I say system, I mean more than one. That's it. So let's look at a system of fruit. Well, I need more than one fruit. I need a grape and I need an apple. In terms of equations, that means I have two different equations, or three equations, or four equations. For the sake of this unit, I'm going to be talking about two equations. So it's going to be a system because it's more than one. So far, so good. It's just a fancy way of saying more than one. We have more than one equation. So when I say system of equations, we're talking about two equations. Linear. This is an easy one. We just talked about linear stuff our last 3 units. What does linear mean? What type of shape of a graph are we talking about? What are the rules of linear functions? Yeah, Gunnar again?
Line.
Line. There it is. Everyone write it down. It's a line. Thank you, Gunnar. You can turn in your card if you haven't done so already. Linear. I'm talking about a line. That means every time I move one in the x direction, I'm moving a constant amount in the y direction. The slope doesn't change. Line, and it has slope. Has slope. If we talk about things that are curvy, like this graph or this graph or this graph, those do not have slopes because they are not lines. Slope is only with linear functions. All right, so solution. This is something a little bit different from what we know. Can anyone define what a solution meant in terms of a graphical representation? Say I had this line. What does a solution mean in terms of a graph? Yeah, Fernando. 2 points. You're close. I'll give you the correctness because technically both of those are solutions. 2 points. I'm guessing you meant to say on the line? Yeah. So a solution is any point on this line. You don't need to write this down. This is just you listening. Any point on this line is a solution. But here's the thing. If I have more than one line, let's say I have 2 lines that look like that, there is only, well, there could be one solution. There could be no solutions, and there could be an infinite solutions. Generally speaking, I would say if you had to randomly put 2 lines on a piece of paper, 99.99% of the time, you are going to have one solution. That one solution is where those lines intersect. It's the solution where it satisfies both equations. We're going to be talking about that with example 1, but this is what I do want you to write down. The solution is where both lines intersect. Where do they cross each other? If you don't like the word intersect, you can use the word cross. But where do they cross? There's only one spot that happens. I need the x coordinate and the y coordinate. That's what we're doing today. And you can think about this. This is super valuable in terms of how it applies to real life. So I always think, whenever I do systems of equations, I'm always thinking about World War II. World War II, you fire off a missile and you need to be able to intercept that missile by shooting it down with another missile. If you shoot down that other missile, then it goes down. Where does that happen? Where do these two things intersect? It's super, super valuable. Unfortunately, that deals with curves, but for now, we're going to be dealing with lines as a building block to start doing curves. Yeah? No? Okay. So let's look at example 1. I just want to know what it means to be a solution. We have 2 different homework assignments. One homework assignment looks like these first 2 examples. The next homework assignment looks like example 3 and example 4. So 2 homework assignments. Let's look at the first one. For example 1, I have these 2 equations. I need to know if 2, 3 is a solution to those equations. All right, quiet raise hand. Which of these is the x? Which of them is the y? For 2, 3, which of them is the x? Which of them is the y? I want to see a ton of hands here. Ton of hands. Julian.
2 is x and 3 is y.
Yeah, label it. That's your x. That's your y. Julian, you can turn in your card. That's my x, that's my y. So I'm going to sub them into both of these equations and see if they work. All right, so someone help me substitute 2 and 3 in for my first equation. Someone read me what to do. Jessica.
You multiply 3 times 2.
3 times 2.
And then minus 2 times 3.
Minus 2 times 3. And what's the other side? What's the rest of the equation? Equals 0. All right. Jessica, can you do that for me?
6 minus 6.
Does 6 minus 6 indeed equal 0?
Yeah.
All right, so we can say 0 does indeed equal 0. Give it a giant check mark. Yes, that did work. Thank you, Jessica. You can turn in your card. All right, I need another volunteer. Help me out with my next equation. People are still writing, Go for it, Sergio.
2 times 2 minus, no, plus 5 times 3 equals 19.
All right, go ahead and multiply 2 times 2 for me, Sergio.
4
4.
plus 15 equals 19.
Does 4 plus 15 equal 19?
Yes.
Yeah, 19. You can say we simplify that to 19 is equal to 19. Yes, check mark. If both of them have check marks, it satisfies both equations, then our answer here, and we're going to box it, yes. Yes, this solution is where those two lines intersect. If I were to graph them, they would graph and they would intersect at this point 2, 3, and we're going to box it. And I need to change my box here. I need red outline, no inside, yes. Any questions before we do the same type of example? I have a question, and then let's see if someone can answer it. If one of these is like 3 equal to 0, and one of them is 19 equals 19, one of them works and one of them doesn't, what would I say here? Quiet raise hand. If this one didn't work, but this one did work, what would I say for my answer? Yes or no? So with a, and it could be a maybe, I guess, maybe. Quiet raise hand. Is it a yes or is it a no if one of these did not work?
No.
Quiet raise hand. If one of these did not work, would it be a yes or would it be a no? You get a 50-50 shot of making this. Is there a quiet raise hand? Fernando, did you already turn in your card? Eder, go for it.
No.
It would be no, yeah. It has to be both equations. Thank you, Eder. Eder, you can turn in your card if you'd like. All right, so next example. I'm not even going to tell you what to do. Someone tell me what to do. Example 2, what am I doing with this possible solution? Is there a quiet raised hand that wants to tell me what to do? I only have 7 cards out of a classroom of 12. That means there's 5 people out there that can participate. What am I going to do? What's my first step? Otherwise, I'm going to cold call on you. Someone that still has their card. I'm going to choose Jenny. Careful here. So this is the, I'll label this one for us. That's our X and that's our Y.
Oh, it's 10.
2 times 10. Good job. Continue on.
Minus 6.
Minus 6 times -1. Good. And thank you very much. Jenny, you can turn in your card. All right. Who's going to help us with our multiplication and simplification on our left-hand side? Quiet raise hand. Otherwise, I'm going to cold call. And did I give? I did. Okay. Jose, did you have your card turned in? No? Okay, go for it.
Okay, so
20?
minus -6
-6.
equals 26.
And then these are double negatives, so plus, they kiss, and then I'm going to get 26 on the left, 26 on the right. So is that good or bad? Good. That is a solution to that equation. Now we have to check that it's a solution to the next equation. Thank you, Jose. You can turn in your card. All right, next up. What am I going to do? Don't make me cold call on you. You know that you're one of the last people. Yeah. Monty, go for it.
10 equals -4
Times -1 plus 2. You said it so fast, I couldn't keep up. Yep, there it is. Thank you, Monte. All right, who am I missing? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 2 people left. 2 people left. Who are they? 2 people left.
It's Josie.
Josie and Cohen. All right.
And Julian.
Who wants to do this one? You have to simplify the right-hand side. Volunteer, otherwise I'm going to call on one of you. All right, Josie, you're going to go for it. How do I multiply 4 and -1? So careful, it's a negative times a negative. All right, +4 plus 2, and then simplify this a little bit more. So I'm going to read the left-hand side. Go ahead and do it for me. Left-hand side is, I just want you to read the whole equation. 4 plus 2? 6. Does that work, Josie? It does not work. So give it a giant X. It does not work. 10 does not equal 6. And Cohen, our answer here is no. All right, both of you turn in your cards. All right. So that is one homework assignment. Let's get ready for our next homework assignment. There are 2 types of ways that they're going to have you graph. Both of them you've already seen. We've seen this form and this form. Everyone can participate multiple times. What is this thing called? What form is this? It's blah, blah, blah form. This one is blah, blah, blah form. What is the left one called? Jose? It is standard form. Everyone write it down. Standard form. Thank you, Jose. What about the one on the right? What type of form is that called? Starts with an S. 2 people know. Sergio.
Slope.
It is slope intercept. And again, if you forget this one, there's slope from M, the y-intercept, slope intercept form. Thank you, Sergio. All right, so what were the steps when I have standard form? Does anyone remember how to graph standard form? There are 2 steps, and then the 3rd step I already gave you, which is to connect both of these points, point 1, point 2. Same thing with this one, connect point 1 and point 2. What do I have to do to get my points from standard form? Who remembers? Jose kind of remembers, Sergio kind of remembers, Andres kind of remembers, definitely remembers, maybe. We'll give it to Andres.
So to get the X,
To get
wait,
the X.
X. No, to get the X, you have to times B times U.
Times what?
0.
Yes, you have the correct words out. So I set y equal to 0 to multiply 0 to b to get x. What are you really finding?
The X coordinate.
The x
Got
starts with an I.
Intercept.
There it is. Write it down. X-intercept, and in parentheses, set y is equal to 0. That'll give you 1 point because the y coordinate is 0. The x coordinate will be whatever x is solved at. So that was good job remembering, Andres. Julian, good job remembering that it was the intercept. Julian, what do I do for the second point?
Find the Y.
You find the y-intercept. And you do that by doing what? By setting
Setting the
x to 10? To 0. There it is. Thank you. All right. That is how you graph standard form. We're going to be doing that in example 3. Example 4 is going to be slope-intercept form. How do I graph slope-intercept form? Who can remember? What do you do first? Jose.
You put B on the graph.
B on the graph. What is the B called?
Point.
It's one of these two.
Y-intercept.
Fernando. It is indeed the y-intercept. I'm going to give it to Jose.
Come on.
You yelled it out. You didn't raise your hand. You got to give him time. All right. So, and then Jose had this correct, which is you need to use the B. The B is the y-intercept. So thank you, Jose. If Fernando, you had raised your hand and then he called on you, I would have given it to you.
I don't do that.
All right. What do I do after I graph this y-intercept? Well, the only data I have left is using this. How do I use this to get my second point? What do I do? Ah, there's a quiet raised hand, Fernando. Yeah, what do I do?
Find M.
Find, well, usually it gives you M. It'll say M is 2. How do I use the fact that M is 2 to find the second point? And you basically have to restate what I just said back to you.
Wait, what?
Use what to find the next point? Use, or what is it actually called? Yeah. So use slope for next point. We'll squish it in there. So if I start from my y-intercept, from my y-intercept, I use the slope to get to my next point. So I might go right 1, up 2, or whatever from my y-intercept. And then I'll have my 2 points, and then I connect them both with the line. Good review. Let's give Fernando his XP before we forget. I put him on the spot. All right, let's go ahead and do this. Example 3. We need to graph both of these equations and find out where they intersect each other. That is the whole idea of a solution to a system of equation. Where do they cross? So let's look at this. We're going to find where these two lines cross by graphing them. How am I going to graph this standard form equation? Well, you have the steps now. What is my first step? There should be everyone raising their hands. I just gave you the steps. What is my first step for graphing standard form? Gunnar.
X-intercept.
Okay, so we're going to find the x-intercept by setting
3
which 3?
X, 3X, 3Y.
What are we setting 3y to? You said set 3y to call on someone else if you want some help.
Zero.
0, yes. So this 3y is going to be set to 0, which means I'm going to be left with 3x is equal to 9. I set the 3y equal to 0, it went away. I'm just left with 3x is equal to 9. That means my y-coordinate is 0. So I'll even set that up for us. My y-coordinate is 0. X comma y. How do I find my x-coordinate? Someone, quiet raise hand. Did I give Gunnar his XP? No, I did not. Julian,
No, actually.
what do I do?
Wait, to find the.
To find x, this x-coordinate, I'm missing it. How do I find that? Using this equation now. What do I do to both sides of this equation to solve for x, Julian?
Huh?
What do I do to both sides of this equation to solve for x?
Divide by 3.
There it is. Divide both sides by 3. Divide both sides by 3. X is therefore equal to what, Julian?
Ooh.
9 divided by 3 is.
Huh?
9 divided by 3 is.
I'm just looking on. Alright.
3. Yep. X is 3. 9 divided by 3 is 3. Therefore, my x-intercept is 3, 0. Let's go ahead and graph that. It really helps to have a color here. And I just now realized that we should have gotten rulers. All right. Let's take a pause. Everyone go ahead and grab ruler. Welcome to Geometry. We're on lesson 5-5. Today's date is January 28th. Make sure you have that date and your name on your notes. Here we go. Review. Our review. If I have this angle of reference, we'll call that theta, and I already gave you adjacent, opposite, and hypotenuse, what is sine? What ratio is sine? I should be seeing like tons of hands, like half of the class. 9 people should be raising their hands. Cheyenne. It is indeed opposite over hypotenuse. Write it down. Make sure you have it in your notes.
Opposite. Synonym, a pen. A pen over fun.
And then Martine participated for our warm-up. Thank you, Martine. Now everyone's up to date. You can turn in your card. Thank you, Cheyenne. All right, cosine. What is cosine? Tons of hands, tons of hands, tons of hands. Chewy.
Adjacent over hypot.
Adjacent over what?
Hypot.
Over what?
Hypot.
Over what?
Hypot.
Okay. Well, we'll take it. We'll say it's hypot.
Do you know who Key and Peele is?
I do.
Yeah, did you see their one on hypotenuse?
I did not. I need to watch it.
He's like, I was
Mathematical
on
humor? That is so me. And then tangent. Tangent is Emily.
Opposite over adjacent.
It is indeed opposite over adjacent. It makes the oa sound. Toa, soa, ka, toa, soka, toa. There we go. All right, so let's talk about going backwards. In math, we want to go forwards and backwards. Sometimes it's impossible when we get to higher level math. Nice shot. All right, so how can we solve for theta in this problem? Sine of theta is equal to 1 over 2. Sine of theta is equal to a half. How do I get theta by itself? How do I undo sine? How do I go backwards from sine? And you can do it. Does anyone know this already before I jump into it? No one knows? Cool. All right. So here's the answer. You go backwards by taking the arc sine. Sine to the negative first power of this side, and you take sine to the negative first power of this side. This is pronounced arc sine. We take arc sine of both sides, and by doing that, go ahead and write this down too, we cross out the arc sine and we cross off the sine. We're left with theta by itself. Arc sine and sine cancel each other out. To go backwards from sine, I take arc sine. So far, so good. This is the logic. This is something that we've done already. If I take the opposite over hypotenuse, so let's actually say I have an angle. We know how to do this. If I have an angle and I take sine of that function, it will tell me what the, I keep saying this so backwards. Before what we had for a warm-up, we had this angle, and then we were trying to figure out what these ratios were. We can all nod our heads. We were trying to figure out what was this side. In order to find the side, we had to take sine of this angle to find what that was. So I'm going to write here sine. We had an angle, we took the sine of it, and it gave us the opposite over the hypotenuse. Well, what if I started with 1/2, just like this original problem, and I want to go backwards to find the angle? That's what we're doing today. Today is going backwards. This is backwards here. Backwards means we take the arc sine. So if I have opposite over hypotenuse, to go backwards, I take the arc sine to find the angle. And I can go forwards again by taking sine of that. And by the way, if I do that on my calculator, just to see what that turns out to be, make sure that radians is shown. That means I'm in degrees. We just went over that for the warm-up also. If I take sine of 1/2, so 1 divided by 2, oh, I don't know why I said 5 there. 1 divided by 2 is 1/2, and I take arc sine of that. The way that I do that on my calculator is I hit second, and now I have the sine to the negative first power, which is arc sine. Arc sine of 1/2 is 30. The angle here was 30, so we can write down also if you, well, what just happened? There we go. We can say that our angle here was 30 degrees. All right, so how do I analyze our inverse trig functions? So these are all of the 3 inverse trig functions that you need to know. I take arc sine of opposite over hypotenuse, and it spits out our angle. This will be equal to an angle. So we can say theta is equal to this thing. Theta is equal to this thing. It's equal to all of these things. Another way of saying this is by actually saying arc sine. This is valid. Instead of saying sine to the negative first, you can just say arc sine. They're the same thing. And it's pronounced, as I've been saying, arc sine. Let's all say that together just to make sure we got the pronunciation right. On 3, we're going to say arc sine. 1, 2, 3. Oh man, that's a handful. Easy money, right?
He takes it out.
All right.
Yeah, that's what
Then we have arc cosine and arc tangent. All of those we know, we have seen them. Let's move on to a misconception that I hate. I hate this so much because this is really poor notation. Whoever invented the notation, we need to look them up and then give them evil glares because they have horrible notation. So this is true. If I have 3 to the negative first power, it is indeed equal to 1 over 3. But sine to the negative first power is not equal to 1 over sine. So don't think of this as 1 over sine, just think of it as arc sine, its own function that goes backwards. By the way, 1 over sine, this does have a special name if you guys want to know it. This is Algebra 2 level stuff. This is called cosecant, CSC, cosecant of x. You'll never need to know that for this class, not until you get to the next class. What's up? Why is your hood back on?
Sorry, I was... Really? No, that's nice. You don't even grab handfuls. You don't even grab handfuls.
That's like a
A
Google
Google
handful.
Okay, I'll do bigger handfuls.
Thank you. Because if you were to grab a handful of
Example 1.
chips, it'd be a lot more than that.
Trying to call me fat, I see. Example
No,
1.
Gold chips, like gold. You grab a lot more of a handful of that.
Oh, okay. I thought chips. Okay. Find the measure of angle B. So they gave us the ratio. They gave us this ratio, and we need to find the angle. They gave us this ratio. We need to go backwards to find the angle. We're going to be doing a backwards function, an inverse trig function. All right. First of all, we need to figure out which trig function we're using. Quiet raised hand. Which trig function are we going to be using? So, ka, toa. Which of those are we going to be using? Quiet raised hand. There's only 2 people that know. I mean, you have a 1 in 3 chance of getting it. You're either going to say sine, cosine, or tangent. One of those 3. What are they going to be? I'm going to wait for one more hand. We have 4 hands so far. There's the 5th hand for Caroline. I'm going to call him Larea. It is indeed tangent. Tangent of that unknown. I can put question mark here if you want. I can put theta there. You can put x there. Whatever you want. I'm going to put theta because that's the general way that we say things. Tangent of theta is equal to, let's come back over here and give Larea her XP. And then what is my fraction? Quiet raised hand. Larea answered. What is my fraction, India?
65 over 30.
65 over 30 like that? Oops, 65 over 30 like that?
No,
No?
it's 30 over 65.
Ah, there it is. 30 over 65. That is indeed correct. So thank you, India. Also, I forgot to give Martine and Emily. Okay, now we're all caught up on marbles. And let me see if I caught up on here. Good, India's all caught up. Okay, so I have this function set up. But now I need to solve for this theta. I need to somehow undo tangent. What am I going to do? Quiet raised hand. How am I going to undo tangent? There's only one person that knows. Raise your hand if you have a card and you know. Only one person, 2 people kind of Leo, no? Okay, Ellery.
You multiply by negative or arc tangent.
So yeah, you're correct in using the arctangent, but the way that you said it is a little bit off. You say you take the arctangent of both sides. So take the arctangent of that side, take the arctangent of that side, and that will cancel out our tangents. So we have an arctangent and a tangent. I'm just left with theta. Now we're going to be approximating because we're going to be rounding, so I'm going to do our little squiggly approximating equal sign. All right, I need someone to pull up their calculator. Do this for me. Someone do 30 divided by 65 and then take the arctangent of it. So Ellery, you got your XP and marble. Someone new, someone that hasn't participated yet. There aren't many chances to participate in this lesson, so I need everyone to participate today. Even if you have participated, go ahead and do this on your calculator so you can be confident in your ability to use your calculator on your phone. Do 30 divided by 65. Take the arctangent of it. Make sure you're in degrees. What is our angle? Uh-oh. Did you do 30 divided by 65?
I don't know if I did right. You do 30 divided by 65, and then you do the other thing.
And then hit equals to get what 30 divided by 65 is. So 30 divided by 65 equals.
Wait, it's supposed to be in degrees or?
It needs to be in degrees, which means Radians is in the bottom left. It shows radians in the bottom left. All right, Aurelio, go for it.
No, I'm just kidding.
Beverly, go for it. Do you have your participation card still?
Yeah.
All right, go for it.
27.49.
4.49, yeah, that is the right answer. All right, so let me show you guys how to do this on your calculator.
Wait, I got 11.4. You're wrong.
Well, you did it wrong.
You're wrong.
All right, so make sure that radians is showing in the bottom left-hand corner. That means that you are in degrees.
You just in the bottom left.
All right, now I'm going to do 30 divided by 65 equals, it's this decimal 0.4615, blah, 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 blah. Now, this represents a fraction. Now I'm going to take arc tangent of this fraction. So make sure it's tan negative 1. You have to hit second to get there. Tan negative 1 of that, and you, ooh. Uh-oh, that is not quite right. Should be 24.775.
What?
30. No, I put sin. I did a sign. Sorry.
You did arc sine? Ah, okay. You sinned in my classroom by using the wrong function. So 24.7. All right, I need someone to round this correctly for me. 24.7. Quiet raised hand. Beverly, why you do this? Martine. Yeah. Thank you, Martine. Did I give Beverly or Aurelio? No. Beverly, you knew what you were doing. You just took the wrong function. Martine, you rounded it correctly. Wait, Martine, you already participated.
Oh my god.
All right. Go ahead and box it. That's our final answer. Don't forget your units. What were our units here? Degrees. That little symbol. Degrees. Kind of like Fahrenheit. Degrees. That is degrees. If it doesn't have a unit, that means if it doesn't have this symbol, then it's in radians, which is not what we were doing. All right. Radians is unitless, by the way. So let's go on to example 2. I want to find this unknown angle. We'll call it theta. Round to the nearest thousandth. So first question that I have for you. Which trig function are we going to be using? You have a 1 in 3 chance of getting it. It's either sine, cosine, or tangent. Raise your hand if you know it and you have your participation card still. What trig function can this be? I know there are some people that know this that already participated. What trig function? 2 people know. I'm going to wait for 3 people. Wait for 1 more person. I might. 1 more person. Which trig function is it? Aurelio.
Yeah, that's right. Cosine. No,
It is indeed cosine. Cosine of our unknown angle theta. We'll call it theta instead of question mark. All right. Thank you, Aurelio. You are in Class Dojo, which is going to load right here. Nice shot. Ooh, cool sound. All right. Coming back here. I need this fraction to be set up for cosine. Who can help me set up that fraction? Quiet raised hand if you have not participated before. There's only 1 hand. Uh-oh, that's not good. I'm going to wait for 3 hands. 2 and 3. Caroline. 7 over 9 like this. That is indeed correct. Thank you, Caroline. All right, and now what am I going to do to both sides? I need to get theta by itself. Right now, theta is trapped inside of this cosine function. What am I going to do to both sides? I see 1 hand. I need to see 3 hands. 2. And 3. Colby. Arc cosine of what? Arc cosine to both sides. There you go. Arc cosine of this side. Arc cosine of this side. All right, thank you, Colby. All right, and our final volunteer for today. Use your calculator. Find what arc cosine of 7/9 is. Arc cosine of 7/9. Everyone be doing it on your calculator. Make sure you know how to do this. 7 divided by 9 equals this. And then I'm going to do arc cosine of this. And you're going to have to round correctly. Raise your hand if you have an answer and have not participated yet. I see 2 hands. No, you've already participated. Go for it, Sam. 30.94 like that. 38.94. 38.94 like that. Degrees. Let's check it out. So we took the arc cosine, 38.94, and it was rounded correctly. Good job, Samantha. And last step, Samantha, is to box your answer. There it is. Thank you, Samantha. You can turn in your participation card. XP, marble, all the jazz. All right, are there any questions about this lesson? Any questions? All right, if you have not turned in your participation card yet, please do so now, and then you may begin on the summary. After the summary, you can begin on the homework. You have paper homework or Khan Academy homework. It is up to you.